is to discuss the introduction to what is J2E all about and how do we go about learning JEE. J2EE or JEE, JEE stands for Java Enterprise Edition. It was earlier called J2EE, Java 2 Enterprise Edition. So we understand that what we have done so far in our course is to learn foundationally, fundamentally and in fair amount of depth core Java. We understand, given a requirement, how do we go about analyzing, applying OAD to arrive at a series of class designs and further take them into implementation and using best practices like MVC, build a small application to implement our business logic. However, what we want to now understand is not how to build a desktop app, but how do we build a web app. So if you want to understand how does any web app work and get an introduction to the web, the first thing we need to understand is where does the web work? Obviously, the web runs on your internet. So today's session is going to be a kind of a free rolling session where most of the things that I will be talking about are many of the things that you already know. So I would want you to interject and answer, and of course at the same time ask me questions. So tell me please, what is the definition of an internet, or what is an internet? What is internet all about? Internet is what? It's a network of network, very good. Of network, very good. Of, what is the end unit? Obviously, I don't know, end unit is not a network. Come on, network, internet is a network of what? At the end unit. All you can say is, you don't want to say computers, because not only computers are connected to the internet today, there are all myriad set of devices. Name me some of the different types of devices that are connected to the internet. Obviously you have your PCs, personal computers, you have your laptops and whatnot, other types of systems as we call them, and then what else? You have your servers, you have your mobiles, what else? Sorry? Appliances, very good. Appliances, like you have many of these fridges and then microwaves, etc. connected to the internet, isn't it? Home appliances, then what else? You have your embedded systems, you have your routers, you have your modems, things which we don't see, right? You have your buses and so on and so forth. Then what else? You have your printers, right? All kinds of different peripherals. You have things like even cars, vehicles are connected to the internet, right? Tesla car, BMW car, and so on and so forth. Bottom line, there are a myriad set of devices which are connected to this so-called common network called internet. Everybody knows there is nothing special there, and obviously we use the internet on a daily basis. But I want to start from scratch so that we don't leave any gaps in our understanding. So this is what is the internet we understand. It's a network of so-called devices. Well, tell me, who governs the internet? For a device to enter the so-called network is like a coterie of sorts, isn't it? You want to enter it, you got to get some kind of a permission, so to say, isn't it? So how do you enter an internet? Is by using, how does a device enter the internet? Is by using, hello? Yes. So the gateway to the internet is governed by your ISPs, isn't it? Internet service providers, isn't it? So these service providers are the ones who forms the gates of the internet, and if you want to enter this network, you got to go via this gate. It's as simple as that. Well, just like you have your school network, alumni network, that is, you have your Uttara network, you have your neighborhood Vatara network and whatnot. You have different networks that we can belong to. But when you belong to a network, the most important thing is every participant in the next network must be given a unique what? Identity, isn't it? Because for you to, what is the whole point of being in a network? There are many parties in a network, participants in a network, and what is the big benefit of being in a network is you can communicate and you can share information or data, isn't it? But when can you share information or data is when there is an ability to uniquely identify every participant, isn't it? So which is the reason why we say that once any device is going to get onto the internet via the ISP, what does the ISP assign to every participating device is an unique IP address, isn't it? Give me a rough number. How many devices are connected to the internet at more or less all points in time? Approximately, yes? How many devices are connected to the internet at any point in time? Throw me an andaj number. How many? 4. Very good, very good. 4 what? Yes, roughly about 4 billion devices are connected to the internet at any point in time. If there are 4 billion devices, each of the device must be given a unique IP address, isn't it? But how does that work? Well, let's understand this ISP. Is there one ISP in the world, or are there many ISPs? Many ISPs, obviously. They are region or locale specific. Companies will apply for this ISP, what do you call it, certificate or whatever you call it, subscription. And once it has been approved, you have ISPs typically for a locale, right? So India has like 3-4 ISPs, America has some 3-4 ISPs, and many ISPs, and so on and so forth. Each ISP is what will now give the internet services to its vendors or to its customers, right? And any customer device, when it connects via the ISP to the so-called network, the IP address is going to be assigned, isn't it? So which means if there are 4 billion devices connected to the internet, 4 billion unique IPs have to be given. But how does that work? Well, even when there might be a device connecting in India to the internet, at the same time a US device might be connecting. How is it that each of the device is given a unique IP? First of all, what is an example of an IP? IP is nothing but a bunch of digits. It's like, for example, 122.166.11.177. And tell me more about IP address. Technically, IP addresses are classified as dash and dash IPs. IPv4 and IPv6, right? So that's a technical implementation which gives you a broader range. Let's not bother about it. That's not too important. But what is important for us to understand is, the 2 buzzwords that are associated in software for everything that you learn: dashic and dashic. Yes, static and dynamic. So we have static IP addresses and dynamic IP addresses. Tell me, static IP address, obviously by its name itself, is suggestive that once an IP has been assigned, that IP will not change. Even if the machine or the system shuts down and restarts, what will be given to it as an IP is the same one. In this case, static IP means the same IP is given to the device no matter what, isn't it? Dynamic IP, by the very name itself, is suggestive that every time the device tries to enter this so-called network via the ISP will give it a brand new identity and a brand new IP address, isn't it? That's dynamic IP. Now, answer me this. How do ISPs give unique IPs to each of the device? Because there are hundreds of ISPs and there are millions of devices connecting to the internet and getting off the internet. So how does an ISP ensure that the IP that is given to a device is unique across all the other ISPs as well? How does it ensure? Sorry? How do you think it works? Come on, this is common knowledge. Janaka, anybody? How does the ISP, like for example, you have Airtel as an ISP or your BSNL as an ISP. When you are trying to connect via an Airtel modem or Airtel broadband to the internet, for you switch on your machine and you turn on your device, then automatically a handshake happens between our device and the ISP provider, isn't it? And that is when an IP will be assigned. If we have not, by the way, let me ask you, do our devices, our PCs and laptops, do we get static IP or dynamic IP? Static IP. Because the IP of C is always 192.168.100.1. Yes or no? Yes or no? Completely wrong. Okay? Almost all our devices, be it your mobiles, be it your laptops, desktops, doesn't matter. All the types of broadband that you use, you are only going to be assigned dynamic IP, not a static one. Because if you want a static IP, you got to pay extra money and buy it, you see. And typically static IPs are given only to those machines whose identity should never change. Typically your servers, isn't it? I mean, I and you can actually live in hotels every day and shift our homes of where we stay every day, isn't it? It doesn't really matter. But imagine one day you suddenly come to Uttara and we have a big board which says Uttara venue shifted, okay, classroom shifted, and where? Behind, behind Raste, and we point you to the direction and you are like, hey, right? No, the person did not tell me yesterday at all, and they have shifted the house, the venue already. Anyway, you go and find it, and there is a new classroom. You enter, and you are, more interested in the classroom than the teaching that day. But you attend it. Then next day you go to the new venue. Again on board, venue shifted. Where? Majestic. This is horrible, don't you think? Obviously, what is it that should be discoverable without their address changing are the ones who serves some content, isn't it? Typically what we call them as our servers. We'll talk more about it. Typically only servers are going to be assigned static IPs. All our devices though are given IPs dynamically. There is an important reason for it, we'll talk about it in a minute. But first answer me this question. How is it that hundreds of ISPs across the world ensure that unique IP address is given to all the devices that connect via it? How is it done? Because there are 4 billion devices participating on the internet at any time. How is it ensured? Come on. Subnet mask? No, not based on that. Yeah. This is general knowledge, guys. Everybody knows this. ISPs is what we connect to get an IP, isn't it? But how does the ISP make sure that it is a unique IP? By? Oh, well, what does that ranging mean? You are right. So I'll tell you, who owns the internet? Bill Gates, sir. No, man. So is there any one company or individual who owns the internet? No. Obviously, that is why we say internet is our one of our biggest humanity's success. You see, because internet is used by everybody, but not owned by anybody, isn't it? The only creation of man, which is like that. I mean, we use air, which nobody owns, right? Typically, but even there we have made laws that if at all there is a land that you buy, even the air on that land is yours. Do you know that? Anyway, we'll talk about that later. So clearly, internet is not owned by any one individual, but it is governed, you see, because anything which is not governed will not evolve in a manner which we want. So it is governed through many councils which is there, right? You have W3C, World Wide Web Consortium, you have ICANN, right? All these are agencies and consortiums where many companies and governments, agencies, etc. come sit on the board, and they are the ones who kind of participate in the evolution of the internet. Bottom line, what these guys do is they give a range of IP addresses to each ISP. And if you look at the IP address, right, all IP addresses are geocoded. What does geocoded mean? The IP addresses have within it the information of the location, you see. So when you say 122 dot, this is an IP that is given only to Airtel servers in India, right? When you have 11 dot, that is what is given to the Tata Telecom Services ISP, and all the IP addresses belong to the Tata from 11 range. Bottom line is all IP addresses are geocoded. So what does this organization do who governs these ISPs? They create bouquets or ranges of IP addresses which are locale specific and give it to the ISPs. So which means what? Each ISP is already given a range of IP address. So when a device tries to connect to the internet via it, it will simply pick one from this range and give it. Overall, across all the ISPs, the ranges are not overlapping, which is the only reason why all the IP addresses of the participating devices are unique. Does that make sense? Hello everybody. Even though what I'm going to discuss today is very simplistic and everybody knows more or less everything, even a small gap in our learning is going to create a big crack, which is going to really break our knowledge of web application development. So my humble request, stop me and ask questions. From today, I need you to be more vocal and ask me any questions, even if you don't have any. Create one. All right. Having said that, so this is how your IP address is assigned, right? And we will talk more about static and dynamic in a minute. Or maybe let's talk about it. Why should our devices like mobile phones and homes, by the way, what is typically connected today to the internet itself is an entire home itself. We call them as HAs, right? Home automation systems, right? So your lighting and your waters and vehicles and all kinds of different parts of your home are actually connected to the internet, and you can control them through web apps or through mobile apps, isn't it? Bottom line, we know this. There are billions of different types of participating devices on the internet, each one given a unique IP, but more or less 99% of them are given dynamic IP. My question to you is why? Why are they not given static IPs? Why not? Take a guess. The important reason, which he said is right, the important reason why a server is what is given a static IP is because anything which is static, anything where the identity is known, it is easy to have it be attacked. Just like in the physical world, there is an underworld. There's an underworld, no. All the rowdies and the gundas and the dons, operate in that so-called underworld. Of course, with the police. Sometimes you don't know who is who. Bottom line, just like there is an underworld in the real world, there is an underworld even in the internet, you see, where there are a myriad set of programs and hackers operate, right? And all of these things are all trying to do. What they're all trying to do is to access somebody else's resources, somebody else's computing power, somebody else's accounts, and steal their money, etc. You would have seen today's newspaper. Two Bengaloreans who were working as data entry operators, they took some credentials of. They were working in a bank, and the bank was, I don't know what kind of policies they have, but anyway, they had access to the account information of some US people, and they only transferred some 15 crores into their account. 15 crores, man, into the person's account, and they vanished from the bank next day. And of course, when you get 15 crores, when you don't have any money, what do? They, in the next 1 month, they bought some 5-6 properties, 5-6 cars, everything. And of course, now they are in jail, of course. Such things don't last a very long time. Bottom line, though, is anything which has a static IP, its address is known to everybody. That means it is prone for attacks. That means you got to provide extra levels of security, right? Typically, if you're a celebrity like Shah Rukh Khan or somebody, right? And imagine if Shah Rukh Khan comes to Bengaluru and you get to know that he is living in Mahalakshmi Layout, then clearly, if you know the house you are living in, he is living in, clearly, people will go there. People who love him will go there. People who hate him will go there. And people who are, who like to be audience will also go there. Hey, yaro kallo ditarante nodanappa, right? Or whatever the case may be. So it becomes very easy to attack, isn't it? But when Shah Rukh Khan comes here and we don't know where he is living, then the security for him need not be so detailed as such, isn't it? He's protected, and that is the reason why all our machines are given dynamic IPs, because every time our machine connects to the internet, if you are given a new identity, then a hacking software doesn't know the identity of our machine permanently. It knows it only for the time we are connected to the internet. The moment we switch off and switch on again, our identity is different. It is like we have a new home. If each one of us are changing our homes every day, then the chances of a thief or a robber coming into our home and robbing us is very bleak, isn't it? That's the basic reason why IP addresses which are given to our machines are dynamic. Only those machines where the machines needs to be identified and discovered in the same location every time is what is given static IPs. Like for example, this IP address is the IP address given to our server. So when you log into Uttara portal, imagine if every day you want to log into Uttara portal and I keep changing the IP address, then it is a nightmare, isn't it? So to change the IP addresses every day. So obviously it should be discoverable, which is why server-based systems are given static IPs. Bottom line, whatever the case may be, a device interacts with the backing ISP. By the way, how does it interact with the ISP? How does our device interact with the ISP? How does our device interact with the ISP? Hello? Through network connections. Like what? Maybe if you have a phone, you have a 3G, 4G LTE connection, right? Maybe you have a wired network, right? You have your broadband connections. Maybe you have a dial-up connection, right? Maybe you have your WAN connection. Bottom line is there are multitude of different ways of connecting to the ISP to seek the IP address. Bottom line, once it is connected, it is now one of the 4 billion devices which has a unique identity. Now, what is the whole point of being in a network? As you said, is exchange of data. So obviously, if you want to exchange data, there has to be a governing principle, governing protocol of how the data can be exchanged. Everybody knows what is the governing protocol of the internet which gives the ability for 2 IP address devices to exchange data is called nothing but your TCP/IP, isn't it? Well, tell me, it's all basics which you can easily allude to even if you don't know a priori. What does TCP/IP do? It gives the ability for any device on the internet with a unique IP to communicate with any other device as long as what is known is IP address. So there is a from and there is a to. from IP and a to IP, isn't it? So if the from IP now, what it can do is it can send some data and it can pass it to the device based on the to IP, isn't it? But before you understand how it works, remember this internet is a network, but what kind of a network is it? Is it a network where every device is directly connected to every other device? Is that the way the network is built? No, no, no. Clearly how it works is you have one device connected to another device, that is connected to another device, that is connected to another device, etc. There is no interconnection between all the devices, isn't it? So it is kind of a fragmented network of sorts, which basically means what does TCP/IP also do is provide routing ability, which means if at all this device A wants to communicate with some device B, A and B are IP addresses, let's say. So what will it do? It will create the data, and where will it send the data is to its nearest connected device. It will simply send it to the nearest connected device. It's like, for me to give you an example, I have written a sheet of paper and I want to interact with, the last person sitting there. What's your name, man? I forgot. Syed. Sorry, man. Yes. So I want to talk to him. So I want to send him a personal secret letter. Okay. So what will I do? I will write the letter. I'll say from Vikram to his name. And now I need to send it to him. But I am not connected to him, you see. I cannot directly give it to him. So what will I do? Very simple. I will simply pass it to Aditya and say, hey, take this letter, man. Right? Pass it. And Aditya, being a very nice person, he will see from and to. Because the to is not his name, what will he do now? He will simply pass the sheet of paper back in the general direction of where the destination person is. Are you with me? That means what will he not do is give it back to me. Hey, he is not going to give it back to me. He is a very nice person. So he implements, he has a Ethernet card. No, not physically. If he is a device, there is an Ethernet card which participates in this routing based on this TCP/IP protocol, which passes the data in the general direction of the destination device. So what do we call this data as doing? Not passing. Hopping, you see, that's when we say the data hops from one device to the another and all the device kind of participate, right? So the data hops from this device to this device very nicely. It is not going to keep the data for itself, isn't it? It says, Papa, yargo data hokta de, and it will pass the data, it will do hop, hop, hop. Finally, it will come to the destination machine. As soon as it comes to the destination machine, it sees from to nane. That means the moment he gets the letter, he will now open it and he will read the data. And if he wants to communicate something back to me, what will he do? Again same. There is no synchronous connection between the client and the server, right? There is no connection, direct connection between the two. There is no synchronous connection, isn't it? It's a completely disconnected network. So which means he will also write some letter and from his name to Vikram, and then he will pass on the data. And where will he pass on? Is to the nearest person that he is connected to. Now when the data hops and comes back to me, is it necessary that it follows the same route that it followed a priori? No, it can follow another route, completely different route, isn't it? And the beauty of this protocol is not only it follows a route, it follows kind of the nearest route possible, right? The intelligence has been built in this routing in TCP in such a way that the routing will ensure that the data reaches the destination device as quickly as possible. That means because if he passes some letter, it might go all the way to the other end, isn't it? And if Ganesh is somebody walking there, that fellow might give it to Ganesh, and Ganesh might go up and give to somebody else, then it will never reach me, isn't it? So it has to go in the general direction of where I am. Bottom line, that's what TCP/IP is. That's how TCP/IP works, then that's good enough for our knowledge. But there is a problem here. Can you tell me what two problems might happen because of this way of passing around data? Security, man. This is a big problem. Imagine I have written beautifully, my Gmail ID password is, my Gmail ID is this, password is this, and that is the data that I am passing. As soon as I give it to somebody, that person will simply say, yenide anta nodana, right? And he opens it and he sees. There is nothing stopping us from him opening the data because the entire data he has gotten it, isn't it? And clearly he might misuse the data. That's one problem. What is the second problem? He can change the data. No, he can't change it because there is some kind of a checksum involved, but I got that. More importantly, or more problematically, remember, all these devices which are connected to the internet can go off the internet at any time. So as soon as I write a letter to him, from and to, beautiful lengthy letter I have written, and I give to Aditya. Aditya gets a phone call from, Evalvas, tomorrow you are an interview man, why don't you come and talk to me? Suddenly he walks out of the classroom, right? Now he has taken my letter with him, you see. So this is a problem here. So clearly what should happen is the TCP/IP has workarounds for these problems, isn't it? What are the workarounds? I'm sure you know, or you can easily guess. Tell me the first one. How to ensure if the data is getting hopped between devices, how to ensure that any one of the device doesn't sniff the data, and get a copy, keep a copy of the data and misuse it? What is the implementation of TCP/IP to implement this simple level of security? Encryption and decryption. Perfectly wrong. There is no encryption that is done by TCP/IP, right? Because encryption and decryption means it takes extra time. Alright? So TCP/IP doesn't do any encryption decryption by default, but yet it implements a simple technique based on which not only if the participating in between device, we call them nodes, if the in between node goes off the internet, there won't be a problem. No node will be able to get access to the full data and misuse it. What is the simplest technique that TCP/IP implements? You know this. Very good. Yes, sounds like a packet, isn't it? That means what does the TCP/IP protocol do? Whatever letter I have written, what will I do? I will not give the entire letter to the participating node, isn't it? I will tear that letter into 10 pieces now, isn't it? And that in all the 10 pieces, what will I write? From and to, from and to, from and to, from and to, IP addresses, isn't it? And then I will give some 3 paper letters to him and 3 paper letters to her and 3 paper letters to him, etc. Now, if I just give these to different devices now, each device will get the data and they will pass it in the general direction of the destination, but will any of the device get all the packets? No. That means one person might open. You see, you can't stop them. He might open and he might read. I what, man? Right? Because he has only seen I, okay? And another person is read. Hey, read what, man? Job what, man? Nobody has access to the full data, isn't it? So this is what will ensure simple security implementation, right? In such a way that no one participating node in between get access to the full data. That's one. Second, this also augments our other problem, which is what? If any one of the participating nodes switches off from the internet, what will now happen? If I have not only I have torn this into 10 pieces, I will write into each piece of paper, what will I write? 1 of 10, 2 of 10, 3 of 10, 4 of 10, 10 of 10. This is what we call as checksum, isn't it? Why? Because it is important, the person who receives my letter knows how to stitch it back, isn't it? How will you know how many pieces of paper are there? So clearly, for every piece of paper, I will write down a checksum. 1 of this, 2 of this, 3 of this, etc. So now, I have given some random papers to nearby participating nodes, and some of them hop, and some of them might not reach the destination at all. But as soon as he gets it, he will get all the pieces of paper. For all you know, first he might get 10 of 10. Next he might get 5 of 10. Then he might get 1 of 10. But the IP protocol is the one which groups together the packets and rewires them together, sees the missing pieces, and it will now ask only for the missing pieces to be sent back. So even if any participating node has switched off, the from machine is asked again by the destination machine, destination IP, to send only the missing pieces, and the missing pieces are routed back again. Bottom line, TCP/IP is a fairly reliable and a robust protocol, right? It is unbelievably awesome, which is the reason why the entire internet still works, even though you have billions of devices getting connected to the internet and getting off the internet on a day-by-day basis, right? Very, very reliable and robust. Everybody got that? Hello, everybody? Simple enough, isn't it? Fine. But what we are interested in learning is not about the internet. What we are interested in learning is how do we build a web app. So that means we need to understand, for us to come up with a definition of a web app, we need to first come up with a definition of what is the web. Then we can look at what is an app and what is thereby a web app in conjunction. So we want to understand what is the web. Tell me, everybody, we use the web every day. What is the web? Obviously we know what it is, so let's come up with a simple definition of search. Tell me what is the web, guys? www. Very nice. Yes, web is nothing but www, which is nothing but your World Wide Web. Got that. But what is that? What is the web? Come on, guys. Collection of networks. Network of devices. That is the internet, man. Is the internet and the web same? No, they are absolutely not the same. They are completely distinct of each other. So what is the web then? Pages. Collection of web pages. Collection of web pages. Is that what is the web? Collection of web pages is a website. Isn't it? But I got what you are saying. That is also definitely true. So, but what is the web? Collection of resources. What do you mean resources? What do you mean resources? Data. What do you mean data? Files. Collection of files. I got that. But is collection of files the web? Really? No. What is the web? You know, it's something so ubiquitous and we use it every day. Without the access to the internet and the web, even one day we can't even sleep, isn't it? But we are at a doldrum when it comes to us asking or answering the question of what is the definition of the web, isn't it? So, well, let me tell you, everything you said is right. There is nothing wrong. But it is not any one of the thing you said, because it's an amalgamation of many things put together. That is what the web is all about. We'll come to that in a minute. Bottom line, based on this so-called network which is available, which is called internet through this so-called ISPs, what is now possible? What is now possible are billions of devices of different architectures, physicality, are able to connect to this network with unique IP. And what is possible is, since each IP is unique and a TCP IP gives you the ability to exchange data, data can now be exchanged from one IP to another IP and from that to back. This is what is possible, isn't it? But the problem is, what is not possible is this internet to be used by human beings. I'll repeat. If you are sitting on a machine and that machine is connected to the internet, well, even if you want some data that is sitting in some other machine, how will we get to know what data is there? How will we get to know what is the IP address of that machine? How do I create a TCP IP request, or how do I ask for something? So human beings cannot use the internet directly. This became a big problem. I'm sure you know the evolution of the internet. Internet was originally coined and created as? Internet was not named internet. What was it named? Come on, guys, general knowledge. Okay, where did internet get created from? Sorry? University. No, it got created in US in its defense organization. Right? Internet was initially called DARPANET. Right? And it was mainly built as a set of protocols and a set of participating devices, so that data can be exchanged between the computer machines that was connected in the defense organization. Their defense organization is so huge and they have thousands of participating machines that they wanted data transfer to happen. So to enable that, they actually invented the so-called internet, but gradually it outgrew the defense organization. It went on to universities, it went on to homes and whatnot. In the 1990s, when the PC era exploded, people started buying PCs, personal computers. Then everybody started getting connected to the so-called network. Having said that, even once the internet was created and available for 3 decades, human beings were not using it. Internet was invented in the 1960s only, but no human being was using it, because inherently internet is human unfriendly. Because how do you use this now? Just because your machine has an IP, how do you use it to share data? You need to know other machine's IP, you need to know how this TCP IP works, etc. So inherently internet is human unusable. That is why what became a need was to humanize the internet, right? And that is when what was coined and created is the World Wide Web. The World Wide Web was invented only for one reason: to make the internet human usable. Who was still able to use the internet were machines. Machines and systems and programs built for the internet was able to use the internet, but humans were not able to use the internet for a couple of decades. So to humanize the internet, what was invented was this so-called World Wide Web. And this is not one thing, it's a combination of many things coming together which makes it human friendly or human usable. What is that? And who invented the web, by the way? Who invented the web? Oh. General knowledge, Ray? Tim Berners-Lee, you don't know? Okay. Alright. So Tim Berners-Lee, they invented the web, and they were the first people who said, internet can be utilized by human beings. And what is it that a human being wants to do in this so-called network? What is it we might want to do? If we are sitting on a machine, device A, and it is connected, over this internet, and there is another machine, device B, what might I want to do sitting on this machine? At a minimum, what is it I want to do? What is it I want to do is access the data in the other device. What is data? Data are nothing but normal files, that's all. So all I want to do sitting on this machine is access these files in my current machine, isn't it? So all I want to do is be able to copy or pull the files sitting on another machine to my machine. And like this, I want to do it across all the millions of machines that are connected to the internet. Well, this was the first requirement of how a human being can use this so-called internet, right? To resolve this problem, Tim Berners-Lee created this World Wide Web. And World Wide Web, what is it? To explain it to you, tell me. To give a just rough analogy of sorts, tell me, which is the biggest postal network in this world? Postal network. Indian postal network. You see, it is the biggest postal network in this world, right? It connects more addresses than any other postal network that is there, and our post is one of those very surprisingly super timely service that is provided by our government. One of the few things that actually works, you see. Yes, it is unbelievable of how qualitative our postal network service is. Having said that, what does a postal service include? This postal Indian Post Service which is there, what does it include? The first thing that it includes is every house in this country has been given a unique address, isn't it? So addressing, identification is the first part of this postal network, right? And then what else does it include? It includes, come on guys, involve please. What else does it include? One is the address, and what else does it include for this postal network to work? Post boxes, you see, post boxes where the letters can be put, and what does it include is your postman, isn't it, who routinely goes to all the post boxes, collects the posts and deposits the posts, isn't it? And it includes the TVS or whatever he rides, or a cycle, isn't it, depending on where you stay. And it includes a GPO, a general post office, which is there per locality where all the posts are routed, and from there they are centrally routed back via your sea, air mail, rail, etc. to the destination GPOs. Bottom line, this is what we call the infrastructure of the postal network. The infrastructure includes the identification of each address, the post boxes, the postmen, the vehicles that are used, the GPOs, and from one GPO to another GPO how the posts are sent via air, via sea, via rail, etc. All of these things is what forms the infrastructure. But tell me now, what is the postal network used for? People thought once email was introduced, clearly, because you can send an email to anybody, do you now write letters at all to send information the way it was done a priori? No way. I don't know. Did you ever do this at all in your life? Have you ever sent letters? Oh, very nice. For what reason? I'm not asking about sending invitation cards. Have you written actual letters and corresponded? Yes. Okay, fantastic. If you have done it, I used to do it because back in my time, there was this very, because there was no internet, there was no web, there was no chatting, etc. No. So there were pen pals. Have you heard of this pen pals concept? In a newspaper every week, once a week, they would announce the addresses of people who and their profile in newspaper. And what you could do is you could write if that profile, you liked that person's profile, you could write a letter to that address. And it could be sitting in Russia, America, Armenia, etc. And you write a letter, it will take a month to go, and after one more month, he will send back the letter, you see, and you will get, and you now have a pen pal. Back in my time, the pen pals were pretty famous actually, and there were all kinds of stories and even movies made where pen pals become life pals, you see. That means they become actually partners. You see, they have you not seen all the Sirf Tum movies? No? Anyway, doesn't matter. But once the email came, clearly people thought the postal network would die because this is much more faster. But today our postal network is more successful than ever. Do you know this? They make more money than ever. They are used more than ever. Why? Because what does your internet provide is what your postal network provides. It provides an infrastructure, and the same infrastructure can be used by many services. Tell me some of the services that run on this postal network. Apart from sending post, what else can you send on the same network? You can send money order, isn't it? Before your, Paytm and before your net banking. Clearly, if you wanted to send money from, one location to another location, how could you do that? It was almost an impossible achievement, you see, because your son is studying in, some Mumbai university, and you are in some village in Karnataka, and the father wants to send some money. How do you do that? You can't give it to one person because the person will vanish with the money. You can't open bank accounts for your son because that was not even possible. So how do you pass the money? Very simple. What was connecting the entire country was the common infrastructure of postal network. So in goes the papa into one postal network and gives the money, and the son goes to the postal GPO or post office in Mumbai and he collects the money there. Isn't this awesome? You give money here and they will give money there, and this happens almost in real time, you see. So a new service got invented called money order. Of course, the money order today is dead because you now have direct transfer through ATMs and through your Paytms and your messages and whatnot. Bottom line, what is money order is a service. Same way, what else is there as a service which is more popular than sending letters? Courier service. Couriers, you see, that's how the postal networks now make a killing. Courier service. You don't want to write letters now, but you want to send things, isn't it? How do you send things? Again, the same infrastructure can be utilized. Then you have your flower service. Do you know you have a bouquet service also? If you want to send a rose on February 14th to somebody somewhere, you see, you cannot put that in a courier and send it, because the person who receives it will get a rose which is, dead. And they will think the relationship is over, you see. Instead, what you do is use the flower service. For the flower service, what do they do? You go here and pay the money and tell what flower you want. The postman of that locality, of the destination, will go to a local market and take new flowers and bouquet and tush, put water, everything, and go and give it to who, and who will be very pleased. Bottom line, that's another service. I want you to relate to this example because what internet is nothing but an infrastructure. Internet provides the infrastructure, but what is running on the internet are many services. And what is the web is one of the services that runs on the so-called internet infrastructure. Are you with me? So internet is just the backbone, the physical infrastructure which makes many services happen. Like, name me some services, please. The two most popular services or important services that we use on a daily basis is, one is web, the other is what? Come on guys, you know this. Everybody knows. What is the most used service on the internet? One is the web, to browse web pages and all that. And the other is what? How do I communicate with you? Email. How does email work? Email also works on the same infrastructure. If Jayanagar people, you would not, this class would not happen unless you had the what service? Not web service. VoIP service, isn't it? Video over IP and voice over IP, isn't it? It would not have happened if this was not there. In real time, I move my hand here, there, you see my hand being moved, isn't it? Not like how it used to. Have you seen the streaming of videos just 10 years ago, how it was? I would lift my hand and after 10 seconds, this fellow will lift the hand, isn't it? It's not real time, man. We could not have done this class at all, isn't it? But now it's real time, and that's the beauty of this VoIP service. But again, the VoIP service runs on what infrastructure? Same infrastructure. Then you have other services like file transfer. File transfer where you can transfer files. Again, it works on the same infrastructure. Then along with VoIP, you have other streaming services, right? Other streaming services, all of which use again the same infrastructure. There are ton loads of services, not just one and two, isn't it? And that's the beauty of this so-called infrastructure. Once you create the infrastructure, it can be hedged, it can be used for a number of other services as well. Out of these, the most used services is this. Then of course you have the chatting services, isn't it? You can do real-time chatting, your Facebook chat, Google chat, AOL chat and whatnot, etc. Bottom line, you understand what this means. So out of these many services, the web obviously is one of the most important services, which is what is called World Wide Web, isn't it? Invented by Tim Berners-Lee simply to make the internet human usable. And what does the human being want? He wants to be able to access the files that are there in other machines. To be able to do this, the World Wide Web was invented. And what does it consist of? It consists of many things coming together, participating to make this human friendly. Well, the first thing Tim Berners-Lee invented is that, okay, there are now files that is there in one machine with one IP. Now the human sitting in this machine must be able to dash this file, access, but first he should be able to ask for this file. If you ask for the file, then this can send that file, isn't it? So they envisaged and created a vocabulary called a client and server. The client seeks, the server serves, isn't it? So if a client has to ask, there has to be a mechanism to ask, isn't it? TCP/IP does not give you a mechanism to ask. TCP/IP gives you the mechanism only to send. So what was required and what is required for every service is a new protocol. Every service is backed by a new protocol that sits on top of this TCP/IP. So the first thing they invented is a protocol that gives you the ability to ask for something and get it back. And we know that is nothing but your HTTP, Hypertext Transfer Protocol. HTTP, Hypertext Transfer Protocol, is a protocol that sits on top of TCP/IP, which means anything in HTTP that you use, how is it actually transferred between two participating devices using IP addresses is via packetting, distribution, regrouping. Same TCP/IP protocol itself, isn't it? And what did this give an ability to do? Create a request and the ability to get hold of a response. You can create a request for a file, and what, as rightly said, a file is called as a resource. So what we can do using HTTP is request for a resource to a server, and the server can send a response, and in this response what it can package is the resource, the file that you have sought or sought. We'll come to that. Then HTTP now gives the ability to ask, but then who has to ask? A human being doesn't understand HTTP request and response. Obviously, what was needed now is a user agent. What is a user agent? User agent is a software which the human can use, and what will it do? It will understand human's requirement and convert human actions into HTTP requests. And the user agent will wait to get back from the server HTTP response, and what will be there in the response is the resource. It will take that resource and display that resource to your human being and to your end user. What is this user agent called? What did they invent? Very good. Nothing but your browser, right? So they invented the browser. And what does the browser have a capability of doing? First of all, browser is a software that runs on what side? Client side. And what does the browser understand to do? It knows how to convert user actions into HTTP requests. And it knows how to send that request over a TCP/IP to the destination server IP. And the browser knows how to wait for the response to come back. It knows the moment it gets the response, the browser knows how to take the resource from the response and display or render it to your client. Are you understanding this? So I'm trying to really stitch the story as to how the internet and the web happened from the beginning. Only then we can understand what is a web app all about. Only then we can understand what is cloud all about, big data all about, machine learning all about. Every buzzword of current technology you can make sense only when you understand historically how things came to fore. So in the next half an hour I'm going to stitch the story and explain it to you. Having said that, what does the browser do now? Browser has the ability to convert user actions into HTTP request, wait for a response, and whatever the resource comes back. Resource is nothing but a file. It can display that to the user, isn't it? But then how to display it? If you think about it, how to display the file, the content? Well, if I wanted to explain to you about what we do in the course, when you come to to the institute for the first time, you want to understand what and all is done in the course. Well, We tell you and you understand it, but for remembering what is it you expect that we should give you is a brochure, isn't it? What does the brochure contain? The brochure will contain everything that we told you, but in a worded out form, and along with wordings there could be some pictures and some descriptions and some feedback and some URLs, etc. The moment you have this brochure now, you can access the content very easily and understand more about what the course is going to deliver and the timeline and blah 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 without having to remember what was told to you, isn't it? Same way, what became a necessity now? The ability to display content to the user in a visual manner, isn't it? Just hold on to that for a minute. Now, what does the browser do for user action? It converts it into HTTP requests. But then on the server side, who should be there? Somebody who is waiting for these requests to come, somebody who understands what is being requested, somebody who takes that file that was requested, creates a response and sends it back. What is that kind of a software called as? Which is the contemporary, the opposite partner or the partner of the browser on the server side? Yes, it is what is called as the web server software. What is web server? Web server is not a machine. Web server is not a physical machine. Web server is a software. And where does the web server run? Is on the server machine. And what is that web server software going to do? It is waiting permanently for incoming HTTP requests. And what does the HTTP request contain? What is the resource the human wants? What is the file he wants? And what is the web server going to do? It is going to search amongst the files whether that resource is there, and if it is there, it is going to package it as a HTTP response and over TCP/IP send it back. And now what will the browser do? It will take that resource and display it, isn't it? Well, think about it. How many files might be there in this server machine? Many thousands of files might be there. Well, tell me this, should all files be accessible to the end human being? No. Only some of them should be accessible, isn't it? So a group of resources, a group of files is what must be allowed to be browsed, is what must be allowed to be sought or requested by the user, isn't it? So clearly what became a need was the ability to group together a bunch of resources and then have it be accessible to the end human being. But let me ask you this. Imagine there is a brand new hotel that is open, alright? Some, I don't know, new Shanti Sagar, whatever, okay? So, newest Shanti Sagar, okay? So, one hotel has been opened and you now are walking on the street and you suddenly see this new board and you say, hey, you tell your friend whom you are going with, let's go and check out this hotel. So, you go inside. Now, what is a hotel? Hotel is nothing but a server. It serves resources, isn't it? But then when does it serve the resource? As soon as you are coming in, will the cooks and everybody come in all the plates and come tini. Are they going to give you the resources like that? No way, that's ridiculous, man. What is it you need to do is make a request. You got to make a request for a resource. Then that resource will be given back to you, isn't it? But when can you make the request? When you know what resources are there now. Imagine you go to this hotel and you now sit in the table and the waiter comes and asks you, what do you want? And you ask him, what is there? What do you want? Please tell what you want. If you tell me what you want, I will give it to you. Otherwise, I will not at all entertain you at all. Then you said, no man, I want to know what you serve in your order. What do you want? That's ridiculous here. Only when you know what the server can serve, can you make a request for a particular resource, isn't it? So what is it that is given to you? A menu. The waiter is not going to take you to the kitchen and say, "Neeve ella nodri, nimge enen beku kelri." That's ridiculous, isn't it? What he is going to give you is a menu. And what does the menu contain? A list of all the resources that are served, isn't it? And probably a picture of all the resources as well. So that the picture, it's anyway a fake. But the picture will look so good. Bonda soup, yaradu tagambani. Right? So clearly, to attract us, you will have a visual aid as well. Now, in exactly the same way, if a user has to access the files, if the user has to make a request for a file, he needs to know what and all are the files that are there. And what are these files? The files could be text files, the files could be image files, the files could be PDF files, the files could be doc files, the files could be of a myriad set of different data types, isn't it? So he needs to know, or he needs to have a menu of all of these files, isn't it? And that menu, what do we call this? A group of files with a centralized menu is what we call it as a, hello? No. A group of resources with a centralized menu is what we call as a website. Well, I'll give it to you. What came hand in hand is now, think about it. A website is a group of files, fine. But you need to have that centralized menu, no? And that menu should explain to the user all the files that are there, maybe with pictures and ability to click and ask, etc. So clearly, what became a need was to textually, visually compose data like a brochure, as we talked about, right? And what got invented for this is a markup language, which we very well know is called HTML. What is HTML? I know you know hypertext markup language, but I'm not asking you that. What is hypertext markup language? Is nothing but the ability to represent data or to give information textually and visually about the resources that are there in a server. I'll repeat, you have to explain it. Your website is your HTML is what is used to create a web page, and a web page will typically have connectors connecting all the different resources. Such a web page is what we call as dash page, home page. Yes. So what is a website? A website is a collection of resources centrally connected to a home page. It is the home page which will describe all the resources and give you pictures of the resources, etc., and give you the ability to request for any of those resources as well, isn't it? So that's what is a website, consisting of a web page. Web page is built on HTML. We'll talk about that. But then what should this HTML web page tell you? It will tell you, look, I have a sample resume, right? I have a sample resume, maybe a photo of that sample resume. I have a sample, I don't know, Aishwarya Rai photo or Deepika Padukone photo. Now, all these are the different resources that are there. What is it you should be able to do easily now? You are seeing that these resources are there. You should be able to ask, request, isn't it? How do you ask and request? So there became a need for the ability for the user who sees a web page. In that web page, he sees information about the resource. He should be able to directly ask the resource. To be able to do that, what was invented? Hello? No. Very, very basic. Everybody knows. What? In a web page which describes the resources that are there, for you to ask for one of the resources, what do? Do you talk? Web page, ittamba. What do? You click, isn't it? And that is the technology that was invented. It's called hyperlink. See, the problem is we use this every day. But we didn't know that, we can't even understand there was a day when there was no hyperlinks, isn't it? Your HTML gives you the ability to describe the resources. But then there should be a ability for the user to ask for a resource also. What was invented was hyperlink, and along with hyperlink, what got invented was the concept of URLs. What is a URL? A URL, Universal Resource Locator, as you very well know. What is that? URL is not a link to a resource, even though you can term it that. A URL is a string which represents the path of a resource. A URL is what represents a path to a resource. URL is not the resource, URL represents a path to a resource, isn't it? So clearly, think about it now. How many server machines can be there with static IP or any number? Each server can have how many web server softwares installed and running within it, or any number. Please note, have the distinction in your mind about server and web server. Server is the machine, web server is the software. How many web server softwares can be running in one server machine, or any number? Each web server, what is it we are going to deploy within each web server or web sites? How many websites can be there in one web server? Any number. Each website can have how many resource files? Any number. Now tell me, what should I and you sitting on a client machine be able to access? Any resource in any website, in any web server, in any server. And there are billions of machines, there are millions of servers, there are trillions of resources. So what became a need is to uniquely identify every resource, for which what was invented was the concept of URLs. Tell me the structure of a URL. A URL starts with what? Protocol that we are going to use. All right. And please note, we are talking about HTTP URL. Recently we talked about JDBC URL. That was a unique way to identify a database, isn't it? A HTTP URL is a unique way to identify a resource. Resource is nothing but a file. So how do you uniquely identify it? HTTP://. Now, of the billions of devices which are there, we need to identify one device. We know how to do that. That is based on your IP address. So IP address gives you the ability to single out one machine. Now, in that one machine, whom do we want to communicate with? Web server. How many web servers might be running in one machine? Any number. We want to talk to only one of the web server. To uniquely identify which web server, what is provided in the URL is port number. We know port number is a logical number between 0 to 65,000. It's a logical number which is what identifies uniquely one of the softwares running in a physical machine. Just like post, if you see, when you write the address in a postal letter, the address uniquely identifies what? The home, right? In the entire country, it uniquely identifies the home. But in one home, how many people might be staying? There are many number here. You might want to give one secret letter only to one person. How do you uniquely identify that person? Name. You say to so and so, to eyes and to the eyes of only so and so. Correct? No? Then the address. So in a similar way, one physical machine is identified by IP, but within that machine there might be many softwares running. How is it identified? Is the name that is given to it is nothing but your port number. Everybody clear with what a port number is? Alright. Now, within that web server, what do you want to identify? Website. Because one web server can have many websites. Every website is given a website name. It's a unique name within that web server. Within one web server, the website names are unique. So site name is what is used. Within that, what will be there are resources. So the files. And this forms your URL template. Right? Your URL, HTTP URL consists of HTTP:// identifying the protocol that is used, IP address, port number, site name and /resource. Look at the elegance and simplicity of this addressing. URL gives you the ability to address and uniquely identify every resource in every website, in every web server, in every server across the planet. What a beautiful mechanism. See, now it is all very simple when you know it. The thing is, this was invented by these two guys, right? Tim Berners-Lee invented this URL concept. It did not exist a priori. 2 decades internet was there. Human beings could not use it until all of this were created and came together to make the internet be human usable. Really, we owe a lot to these guys, right? Anyway, so that's what is your URL, isn't it? And what is a hyperlink now? Hyperlink gives an ability for the user to click on a clickable link, and when you click on this link, what is it that will be requested for is a resource via the URL. So every hyperlink is connected to a URL. So when you click it, what the browser will convert that action click of the user into is a HTTP request to that URL which the hyperlink is associated with. We'll talk about HTML and hyperlinks and URLs in a minute. In some time. So bottom line, what is a website now? A website is a collection of files, nothing but resources associated or linked using hyperlinks to a home page. Right? There could be any number of home pages. So what could also be files be are HTML files. So one HTML can be connected to another HTML file. Each HTML file can be linked with any of the different types of files and resources, all connected through hyperlinks and URLs, right? Now, all this is fine. Tell me now, sitting on a client machine, can a user access all the files provided he has access to that home page or not? Provided he gets access to that home page will contain hyperlinks to all the resources, so he can click on it and access all the files as well. But when can he do that is when he accesses that home page. To access that home page, what should the user know? Website name, home page name, your port number and IP address. You think users like you and me will remember all these IP address? It took me 5 years to buy out only our IP address, 122.166.11.177, right? colons 8080. If you look at our Uttara portal's IP, Uttara portal's URL, what is it? 122.166.11.177. Let's see if anybody has seen. What is the port number? 8080. What is the website name? Very good. Uttara ABC / index.html. This is what you need to type in the address bar of a browser, asking the browser to make a request for the home page. But can we remember all home pages link URLs like this? No. That was why, to make it easy for the human being, what was invented? Domain names and domain name servers, right? So to humanize the internet, it became important that a user can remember the websites. How do you do that? Is by mapping your URLs to a particular name which is human recognizable and rememberable, right? So what is a domain name server? Domain name server and what are domain names? Domain names are nothing but logical names that the website developer, the one who creates the website with the resources, the one who wants to expose his resources to the world, creates, right? He buys rather, like www.uttarainfo.com. How many www.uttarainfo.coms exist in the world is only one. So it's all domain names across the world are unique, right? And you can buy these domain name from domain name providers, right? Like Google, like GoDaddy, right? GoDaddy and so on and so forth, right? You can buy and procure these domain names, and once you buy this domain name, what is it that will be done? In the ISP, what are provided are domain name servers. And what do they contain? A mapping between what to what? The domain names to your URL of your homepage. Typically, what does it contain? Is entries like www.uttarainfo.com or hotmail.com. You see, this is a URL now, domain name now, and what will this be mapped to? This will be mapped to http:// IP address : port number / site name. Only till the site name is where the mapping will be done till, right? So this is a URL, and that URL has been mapped now to this hotmail.com. So now what happens now? In your browser, when you type hotmail.com, forget hotmail.com. Maybe you type in, I'm trying to come up with a website name which you have never heard. Have you heard, what is that recent startup in Bangalore which got funded by Google? It's not coming to my mind. Anyway, so imagine you open a, let's say Practo itself, right? So Practo.com. When you type in www.practo.com, how does the browser know where to send the request? What does the browser do? You have typed in www.practo.com. What does it mean? Give me the homepage of Practo.com's website. So how does the browser know where to send the request? Hello guys, come on, connect the dots. Where is your browser connected to? ISP. So it will ask the ISP first time when you type practo.com in your website, in your address bar, it will ask the ISP, give me the URL for www.practo.com. What does the ISP do? ISP looks into its domain name server. What does the domain name server contain? Mapping of domain name to URLs. It will check, is there a practo.com? If it is there, it will simply take that URL and give that URL to the browser. The browser will make a copy of it, store that internally, and now once it has a URL, can it send a request or not? And once the request has been sent, can the response be sent back with the homepage or not? Once the homepage has been received, the browser renders that HTML to the user, and the user can click on hyperlinks and access all the resources of that website or not? And the rest is so-called history, isn't it? So clearly, what if when the browser asks the ISP, look into your domain name, tell me whether the www. Some, whatever, practi.com is there or not. And imagine there is no practi.com, then what does the ISP do? Yes. No error. If practi.com is not there here, what do you do? Imagine you buy a brand new domain name now, www.onlinelungishop.com. Okay, you have entered into e-commerce. If there is an Indian furor in the country that we want to sell India, make in India and all that. So lungi and pajama and kurta and whatnot are all Indian kind of clothes. So online indianclothes.com obviously is a domain name which is taken. So you make online lungi.com or some nonsense. Okay. Now, if you have bought this online lungi.com and built a website, you think American ISPs will have in their domain name servers the mapping? No. So when you type in the browser and ask for a domain name, type a domain name, the browser asks the ISP looks into the domain name server, it will not there. One ISP will talk to other ISP. That other ISP will talk to other ISP. If the entire local set of ISPs don't have it, they will talk to their headquarter, manager ISP, the manager ISP. The query will be asked throughout the entire world. All the ISPs in the world will be asked and the URL will come back to you if it is there anywhere. You understand? What a beautiful implementation, isn't it? And finally, once that entry has been sent back, all the ISPs will make a note now for further usage. And once the browser knows the URL, it simply sends the request. As simple as that. Remember, we talked about that goof up that happened for youtube.com, isn't it? Now you can relate to it very easily, right? In Pakistan, ISP changed www.youtube.com to a URL for their local Pakistan server. They changed their URL, saying that anybody who types youtube.com in Pakistan, it will come to their ISP, and the ISP's URL where it is pointing to is not the Google server, but a local Pakistan server, where there was an error message being displayed, YouTube is banned, you cannot use it by law of government. Do you remember we talked about this? And now, all the people in Pakistan, when they typed youtube.com, it would hit their ISP and the domain name server, what URL it would return is the local Pakistani machine. But not only YouTube stopped working for Pakistani people, it stopped for all Indians and all Chinese and all Europeans as well. Why? Because anybody in India, when they typed youtube.com, automatically the Indian ISP did not, because of the way the ISP domain name servers have been built, because the ISP talked to each other, Pakistani server told the Indian ISP, hey, youtube.com, why you want to go to America server and all that? Nam local server is there, why don't you send request there only? So all the ISPs got the new URL of Pakistan server for youtube.com now. Are you with me? So suddenly in half the world, when they typed youtube.com, where did all the requests go to is Pakistan server. Of course, their server got swamped with requests and it shut down, right? So error message also was not being shown. But talent we know. Anyway, so clearly, when Americans woke up and Google people woke up, half the world is complaining YouTube is down. When they open their machine and type youtube.com in America, it is working, because in America when the request was sent, it goes immediately to their own machine, isn't it? Then they understood this happened, they called up the Pakistani authorities and then said, yeah, change the URL. Then they changed the URL back. youtube.com means go to American server. Then Pakistani ISP tells Indian, right? You have to send there only. Then this took another 24 hours. So any change in the URLs takes 24 hours to percolate to all the ISPs of the world. Anyway, bottom line, we know how the domain name server helps now, isn't it? Because now domain names are easy to remember for the human being, and even if it's not easy to remember, you can dash mark it, bookmark it. Once you bookmark a domain name, clearly it becomes very easy now for you to revisit that website anytime you want. Are you all with me? Everybody clear? Okay, but now, once you know domain name, you can request for the home page. Once you have home page, using the hyperlink, you can make requests for your resources and get access to them. But how will you get to know domain names only? Because there are millions of domain names and websites that are created. How will you know domain names? So what was invented to help in this? Yes, search engines. Search engines, right? Search engines were invented with the sole intention that a human being sitting on a client machine can discover new domain names. He can search for new domain names based on what interested resources, what is his interested resource that he wants. That's why the search engine was created, right? And how does search engines work? We talked about this. So tell me please, how does search engines work? Search engines, what do they do? You will give some keywords based on your interest, Java, job, Bangalore, type. or whatever it is, right? Latest news, type, or latest tech, type, or practo, latest news, type, enter. So when you do this, what happens? The search engine, what does the search engine do? Answer in its name. Searches, very good. What does it search? Entire internet. Yes or no? No. No search engine searches the internet when you search. Search engine will only search the internet when you don't search. We talked about it, isn't it? I'll repeat. What do search engines do? All search engines have software called bots. They are called spider bots. How do spiders move? I mean, if you look at the way the spiders move, it moves on the web, isn't it? It crawls, right? It crawls. Wherever the web is there, it can crawl to that place, wherever the connections are there. So, anyway, all search engines have softwares called spider bots. What do spider bots do daily? Daily, they go and interact with ISPs, domain name servers. What will be an entry made into domain name server? Come on, guys. What is entered into domain name server every day? New website name, domain name with its URL for the home page, isn't it? Every time a website is hosted and a domain name is bought by a developer, he will buy a domain name. The moment he buys a domain name, into the ISP's domain name server, an entry will be made. The domain name with the URL. Now, what is this spider bots do? Every day they will go to all the hundreds of ISP's domain name servers and they will ask, today what were the new entries that were made? Once it knows what are the new entries that were made, what does it get access to? URLs. The spider bot makes a HTTP request as if it is a browser to that URL. When a request is made to the URL of a website, what is returned back? Home page. Once a home page is returned back, what does the home page contain? Hyperlinks. What does the spider bot do? It simulates a click on each hyperlink. Do you understand? That means it will make new HTTP requests for all hyperlinks, and all hyperlinks are associated with URLs. That means what did the spider bot get access to? That website's all URLs. Now it makes a request to all the URLs. When it makes a request, what does it get access to? All the resources and files of that website. Once it gets all the files, the spider bot will now give it to the search engine indexer. What it does is it goes through all the files. Just like buffered reader, file reader, we open the file and go through contents. It goes through all the contents. It understands it, and what do search engines do is it builds an index based on the words that are there. So it will store. What will it store? For each of the words, based on a weighted analysis, it stores for this word Java, these are the URLs. For job, these are the URLs. Java job, these are the URLs. It stores all the URLs for your keywords. So when you now search for Java job, what does it do? The search engine only searches its index. Against each word, what is there are URLs? It will simply take those URLs and give it to you. That is how search engines, conventional search engines work. Are you with me? Obviously, there is more complexity than what has been discussed, but at a very high level, that was what was the invention that was done by Tim Berners-Lee. Now look at the beauty, guys. If you combine all these 9-10 things, what became an ability now is anybody can develop a website, host it on a web server, and anybody and everybody in the world can discover it based on a search engine, make a request to the home page, bookmark it if they like it, access all the resources. What an amazing accomplishment that two people invented something which the entire population of the world uses today, even now. It is unbelievable invention that these guys did, right? So combination of all of these things is what we popularly call today as World Wide Web. So what is the web? Is not just websites, not just web pages, not just hyperlinks, URLs, domain names, browsers, web server, HTTP, not just search engine, not just domain, all the domain name servers and ISPs put together. No, it's a combination of all of it. All of this coming together to make the internet human usable is what we call as the World Wide Web. And what is the World Wide Web? Is nothing but a service that utilizes the internet infrastructure to humanize the internet. Are you with me? This was the original way the inception of web happened. But today the web is used for all other reasons as well. We will talk about that. But we are still in 1980s. We have to come to 2000s. All right? Any question in what we have discussed so far? because even the smallest gap in your understanding of this so-called web domain will make a crack, as I told you, in your web application development. You cannot afford to miss even a single thing. So, although many of us know this, or although many of us are understanding it is connected and created as a story nicely now, please ask me questions if you have any gaps, if you have any doubts. Any queries? So, I'll repeat it one last time. So, what happens first? A set of developers creates a set of files and they say, I want these files to be accessed by everybody. So, what is it they do? They will build a web page or a collection of web pages. That means they will need to learn HTML. HTML is not a programming language. It's a set of markup. We will talk about that in detail fairly shortly. So, he will create a HTML. Who knows how to present this HTML visually to the user is your browser. So, the developer of a website will create a HTML. They will write, I have this file, this file, this file, this is what this file contains, this is a sample resume, this contains sample Java questions, this contains a video explaining interview questions, this contains a test. They will write all the information, they will show, they will connect with images, and they will give hyperlinks to all the resources. And that website, they will deploy it in a web server. And once they deploy it in a web server, in a physical server, they will now know what is the URL of the website, the IP address of the server, and what kind of a server should it be? It should be a server given what IP? Static IP. Now it will make more sense, because once the user gets access to a URL, what you cannot change is IP address, because there is no way for him to know the change in the IP. So that is why all servers where we host web servers are typically assigned static IPs. You got to pay money extra and buy it. Anyway, so on a static IP machine, the web servers are installed, and in that web server, the website is now deployed, and now there is a unique URL. What is bought is a domain name from a domain name provider, and what will the domain name server link? The domain name to the URL. The moment you do this, who will scan the domain name server are your spider bots, and now the search engines have an entry of your new domain name. Are you with me? Now the user goes to a search engine, types by giving some set of keywords. For that set of keywords, the search engine will search only its index, and your URL will now be dished out. And now the user will click the domain name. When he clicks the domain name, what will be sent is a request. What will be the basic request will be sent for when a request is sent to a website is to the home page. So what will the web server now do? And the server gets the request based on the port. It asks the web server looks at the website name, takes the home page of that website and sends that HTML back in the response. What is the browser doing? Waiting. Once it gets the HTML, what does the browser do? Displays it, renders it to the user. Now, once the user sees that home page, he sees all the pictures and the information about the resources. Now he clicks on hyperlinks. Every hyperlink is associated with a URL. When he clicks it, what does the browser convert user action to? Request to that particular URL's resource. Now request goes and the response is served with the web server pasting that file into the response. Are you with me? And now the user can browse the web, or he can, based on the hyperlinks he clicks, access all the resources. That's why we call browsing of the web as crawling, isn't it? It's called web crawling, right? Or web browsing. Why is it called that? Is because you might start from one website, one home page, but from there you click on something and you land up in another web page, and from there you click on something, you will land up in another website, from there you click on it and you go elsewhere. So all these websites are now interconnected through URLs via hyperlinks. And that means you can now crawl from here to there, to there, to there, to there, to jump around and keep on crawling for the rest of our lives. Are you with me? That the story of how the internet infrastructure is used to humanize it and for the user to access files which are existing across all the machines that exist. Everybody clear? Hello everybody? Guys, it took me at least 10 years to come up with this last half an hour story. Okay? I hope it connects many dots in your minds which were dotted and not a full line. Hopefully it makes sense to you. If you have any doubts, please ask me though. Anybody? Any question at all? No? Okay. All right. Sir, you all okay. But what is web app? Because please note, we are not interested in building browser software. We are not interested in building web server software. We are certainly not interested in building websites. We are not interested in TCP/IP or building anything on HTTP. Then what is it we are interested in? We are interested in building web apps. What are web apps? You tell me. Everybody knows. What's a web app? Yes, sir. App on web. Very good. What is a web app? Huh? What is a web app, guys? Come on. If you want to understand a web app, what is a web app? Web app is nothing but an app. An app is nothing but a collection of programs. It's a collection of programs that run on the web. Not a very good understandable definition yet. So what is a web app? Well, if you want to contrast a web app with a web site, to understand it, the rough analogy is nothing but your, Kirana store, your Shetty Angdi, your Kaka shop versus your hotel, Kadamba hotel, for example, right? That's the difference between a website and a web app. What is the difference? Well, in a Kirana store, what is it you can do? Kirana store is a server, you see, where you can go and make a request for a resource, and that resource will be given to you provided it is there, isn't it? So I can go to a Kaka shop and say, 10 rupees, and say, what, give me Cadbury's Dairy Milk chocolate, right? And what will this Kaka fellow do? He will search amongst all of his items that are there, and if he finds a match, he will give me with a response, isn't it? So I am making a request and I am getting a response, and in that response I am getting the resource that I wanted. However, what kind of resources you can make a request for? Only the resources that already exist, isn't it? If that 5-star or Dairy Milk is not there, you cannot tell the Kaka, avella gottilla, manufacture one and give me now. No. Kaka fellow does not have the ability to manufacture or create anything. But contrast it with Kadamba now. You go to Kadamba hotel, that is also a server. There also you will make a request via the waiter. What request you will make? Give me one fatafat masala dosa. Now, when you make a request for fatafat masala dosa, what will he do? He will go and relay it to the cook, who will now do what? Will he give you the masala dosa that was done 3 months ago? And he will come and say, that is ridiculous. When you make a request, you are fundamentally making a request for a resource that does not exist a priori. But clearly, somebody is now going to perform a set of operations, set of instructions they will follow to create the resource you are seeking for, isn't it? And then that resource will be served to you. In both the scenarios, whether it is a Kaka shop or whether it's a hotel, what the user does is the same thing. They will both make requests. But in one you are making a request for a resource that exists, in another you are making a resource for a resource that does not exist. So what is needed in a web app is you are making a request for a resource that doesn't exist, which should be created. If you want to create a resource, what is a resource? Resource is nothing but a file. If you want to create a file, what should be executed? A set of instructions, a program. So a web app is a collection of programs and resources that are deployed in a web server. Are you with me? And what happens now? When a request is made to a resource, understand it step by step. User types in a URL or clicks on a hyperlink, request is sent for a resource. There are two kinds of resources now, dynamic resource and dynamic resource. Static resource and dynamic resource. What does that mean? Static resource is a resource that already exists. It's a file with an extension that already exists. But a dynamic resource is one that does not already exist. Look at this URL, 122.166.11.177.80.80 Uttara abc/index.html. Is this a static resource or a dynamic one? What does it look like? Static resource. You are saying, give me this file named index.html. But look at other things. If you try to log in, etc., you would have seen Uttara abc/login, Uttara abc/logout, Uttara abc/edit account. What is this? Is this a file you are asking for? No. You are making a request for a resource that does not exist. Are you with me? So this is a dynamic resource. This is a static resource. Static resource is a file name with extension. A dynamic resource is just a text. We call this as URL pattern. URL pattern. It's just a pattern, that's all. It is not a file with an extension. So when you now ask for this request, remember, where will the request go is to your server, and who will be in the server be executed based on the port number is your web server. Now the web server will look into your request URL, it will look at dash and dash, website name and resource. It sees whether the website name is there. If the website name is there, it checks the resource, and it will check whether the resource is static or dynamic. If the resource is dynamic, then the web server will do what? It will call a what? A program. It will invoke a program, and that program, when executed, will create a file, and that file will be given back to web server, and web server will do what now? Create a response. Into that, it will write that file and send it back. Are you with me? That is now no longer called as a website which has programs which can create resources. We call that as nothing but a web app. So a web app is a collection of resources and programs deployed in a web server. Are you with me? Deployed in a web server, where when a request is made for a dynamic resource, the web server will invoke the program of the web application, which will create the resource, give it back to the web server, which will now send it back to the client in a HTTP response. This is the high level understanding of what is a web app. Are you with me? I want you to understand the difference between a website and a web app. Website is a collection of static resources which already exist. A web app is a collection of static resources along with a set of programs. And both web app and website are deployed, housed, hosted inside of a web server. Who manages the web app and your website is your web server. Who is waiting for incoming HTTP request is your web server. Who understands whether the request has come for a static resource or a dynamic one is your web server. The web server, if the request has come for a dynamic resource, will call our program in the web app, and once our program is called, can we write a program which will create a file or not? That file which is generated is a dynamic resource now which will be sent back to the client. Are you with me, guys? That's at a very high level a web app. Clear? Very good. So we want to understand what does it take to build a web app, because that's what we are interested in, simply because that is where the maximum number of jobs are available. In building web applications for automating business rules, enterprise rules. We'll come to that. After the break, we'll talk about it. So web app is what we are interested in building. However, just one small thing to share with you so that the story comes to a logical end. Remember, there is static and dynamic are extremely overused words, right? So far, what have we learned? There is static, IPs, dynamic, IP. There is static, resource, dynamic, resource. There is static, web server, and dynamic web server. What is web server? Web server is a program, a software which is installed on servers, which is waiting for HTTP requests. So web server softwares understand HTTP. They also give us the ability to deploy websites. Static web servers allow us to deploy only websites. Dynamic web servers allow us to deploy within it not only websites but also web apps. Remember the difference between the web app and website. Web app contains not only static resources but also programs that can create dynamic resources. Right? So a dynamic web server is one which allows us to host websites also, web apps also. Static web servers allow us only to host websites. Like for example, Apache web server allows you to host only websites. You can host any website which is static. That's not what we are interested in. We are interested in dynamic web servers because we are interested in building web apps. Remember, web apps contain programs, and obviously if web apps contain programs, the programs are built on a programming language. Obviously, the web server should know how to call a programming language's program. So all dynamic web servers are programming language enabled, or programming language specific rather. Give me some names of web servers that you are aware of. Dynamic web servers. Yes, Tomcat, for example. Tomcat is a dynamic web server which allows to deploy web apps where the programs are built on what language? Java, man, Java. Coffee. Java. Java language, if you build web applications, you can host it on Tomcat, you can host it on JBoss, you can host it on WebLogic, WebSphere, Geronimo, Glassfish. They're all different names of dynamic web servers. Are you with me? There's something called IIS. What does IIS allow you to host? Web apps, where the programs are built on what language? .NET. Thank you. If you have IIS is a web server which allows you to host .NET based web applications, right? Then you have PHP Apache server. What does PHP Apache server help you to do? Deploy web apps where the programs are built on PHP. Then you have Python based web servers, you have Ruby based web servers, Scala based web servers, Django based Groovy based web servers, and so on and so forth. Bottom line is, you have many different kinds of web servers, dynamic web servers at that, because they are all backed by different programming languages. What are we interested in? We are interested in building a web application with a collection of what programs? Java programs housed in what web server? Java enabled web servers, so that our Java enabled web server web application can create new resources when a user makes a request. Are you with me? That is our interest, and clearly this is part 1 of the movie. Abhi picture baki hai. Take a few minutes break. During the break, I want you to think of questions, guys. I want you to ask me questions on how does the internet work, how does the web work. Any questions that you have on about any of these understanding, please stop me and ask, because this is very, very important for us to proceed. What is coming up next is also interesting. Let's take a break.